Right. Let's the IP address first, then we will think about bringing up the BGP sessions. IP address and OSPF inside AS10. Interface loopback. IP address 10.12.0.1. Oh no, loopback is not 1. It's 1.1.1. Okay, I want to know the name of the interface, so I click on this, I get the name. Ten 12.0.1 255 500. All right, let's put the OSPF on both the interface range loopback 0, F IP OSPF 1 area 0. Hmm. Hmm. ரெண்டே ரெண்டு ரவுட்டர் இருந்தா எதுக்கு OSPF தேவையில்லை. அண்ட் அந்த ரெண்டு ரவுட்டருக்கு நடுவுல பிஜிபி செஷனை வந்து லூபேக் வச்சு ஃபார்ம் பண்ணாங்கன்னா லூபேக் டு லூபேக் ஃபார்ம் பண்ணாங்கன்னா OSPF எனேபிள் பண்ணலாம் தேவைன்னா, இல்லையா ஸ்டாட்டிக் ரவுட் போட்டுக்கலாம். அந்த லூபேக் டு லூபேக் ரீச்சபிலிட்டி ஏதாவது ஒரு வகையில் நீங்க கொடுக்கணும். Anyway, we are not going to focus on loopback to loopback right now. So your question was, we have two routers, do we need to run OSPF? If you have just two routers and forming neighbor using the directly connected physical interface address, not necessary. No need of OSPF. Okay, welcome. Now router 1 has got the IP address and OSPF. Let's verify. You can see both the IP addresses on those interface, and also you can see they both are member of area 0 and they are running under process ID number 1. Okay, so far no neighbor has been discovered. The reason is the other routers are not yet configured. On router 2, I'm going to start configuring from loopback interface loopback 0. Always try to configure loopback interface first before you configure physical. The reason is, when you enable a routing protocol or NBLS or any protocol that needs router ID, they first look for loopback interface so that they can elect it, they can use it as router ID. If you don't have loopback, what will happen? They pick from physical interface. Later, if you configure loopback, what will happen? Nothing will happen. You cannot use the loopback interface address as a router ID when already an address is picked. So always configure router loopback first so that it can be used as a router ID by protocols. Okay. Okay, so we have assigned IP address but no OSPF. Show IP OSPF interface brief, nothing. Let's go interface range loopback 0, comma F00, comma F10, IP OSPF 1A 0. Done. Now let's check whether the OSPF is running. Yeah, OSPF is running and it has already formed one neighbor via F00. Via F00, who is connected? Router 1. Whereas on the other interfaces, these are the IP address, but no neighbor so far. The reason is the other router is not yet configured. Router 3 has got OSPF. So it learns route from router 2, show IP route, OSPF. You have learned the route to reach 1012, which is router 1's F00 interface. And when you can ping this address, when you can ping this address from router 3, when you can ping this router 1 from router 3, you can also do any sort of TCP session. BGP is a TCP protocol. You can definitely negotiate BGP. I want to go sniff some packet before I enable BGP. I want to sniff some packet here between R1 and R3. All right. There are OSPF hello packets coming and going. Our focus is not on the OSPF. I'm going to put TCP here. Show me if you get any TCP packet. Okay. Now, you see between 3 and 1, we are going to configure BGP. On router 3, I go and say router BGP autonomous system 10. And I have to say neighbor manually. No network. I'm using what command? Neighbor. I'm not using network command. I'm using neighbor. We have to manually mention the neighbor. We need to mention the neighbor like this: 10, 12, 0, 1. Remote AS. See, because of the word remote, you should not say, you should not think that we are doing some EBGP. No. Remote AS is the syntax. Means it can be a remote router. Sometimes it may be a EBGP also. The command is same for both EBGP and IBGP. If it is EBGP, the number here, what I'm typing now, will be different, like 20. The neighbor is not in 20. For us, this neighbor is in same autonomous system as router 3, which proves the router that this is an IBGP. Now, as soon as I put this, you see what happens here. You will get on TCP packet now. See, it has come. What do you see? Who is sending this packet? Router 3 is sending this packet. To whom it is sending? Router 1. Did router 1 accepted it? No. Router 1 is saying reset, 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 reset. You see, it resets the connection. Router 1 is not accepting this packet. Router 3 is sending, router 1 is resetting. You see, router 3 is sending, this is the source address 10.23.03 of router 3. It is sending, optional, okay, here, option. And if you go down, you will see TCP option. It's a SYN packet. And you see the port number is 179 because BGP uses TCP 129. And it's a SYN packet. You see here the flag, SYN packet. Open this, you can see SYN is set. So router 1 is trying to initiate. Every time you see the purple color is router 1. That's the one which is initiating. But the red color is danger 1, which means there is something to look at. Router 1 says, hey, I acknowledge that I got your packet, but I'm not going to send you SYN. I'm resetting. See, router 3 says SYN set. But router 1 says, no, reset, reset. Why? Because router 1 is still not ready with BGP configuration. Router 1 is not ready to accept router 3 as a neighbor. Because we did not configure on router 1 3 as a neighbor. Listen, when you are in router 3 saying this as the neighbor, this becomes the destination of the packet. What address? 10.12.01, router 1's address. That's what you see here. 10.12.01, that becomes the destination of the packet. What is the source? Source is router 3's exit interface, this one. That's the default source address, right? When router 3 goes to router 1, what will be the source? This guy. Now, router 1 should have 10.23.03 as the neighbor. Router 1 should have the configuration to accept. The reason why this is resetting is router 1 is not knowing this 10.23.03 as a neighbor. Router 1 receives the packet. That's why it sends an acknowledgement. You see here, it says, hey, I acknowledge your packet, man, but I don't know you. You are coming from 10.23.03. I acknowledge you. Acknowledge is set, but I am not ready to accept you. Router 1 says, I don't see your information as a neighbor. So let's go to router 1 and configure router 3 address as a neighbor. Neighbor, which address you should put? Router 3 has got two addresses, 33333, 1023. You should put what? 1023, because from there only packet comes. Whatever the packet source, that should match there. Router 3 is not known by 333 according to this packet. It is 1023. So you should put 102303 and remote AS is 10. Now, as soon as I hit enter, you will see three-way handshake successful. Right now, it's only two-way. You see bracket starts here, ends here. Bracket starts here, ends here. Bracket starts here, ends here. But after I hit enter, it will go many levels, not just three-way handshake. After three-way handshake, BGP open message will go, and then keep alive will go, and then update will go. Yeah. So there is going to be a long TCP conversation once I hit enter between these two router, between these two IBGP neighbors. So let me hit enter now. Boom. Look at this. And this conversation is huge, you see. I click here and you see the bracket continues down, 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 up to here. This is one BGP session. Let us stop this Wireshark and examine these packets. You see, this time when packet was going with 10.23.0.3, router 1 accepted. See, router 1 also says, oh, good, I also want to form neighbor with you. It sets SYN along with acknowledgement. Earlier it was acknowledgement reset. Now it is SYN. And then router 3 says, oh, cool. Now I also send my acknowledgement saying that router 3, I know you, my buddy, come. So both are agreeing, accepting each other as neighbor. But the fin is not set. It is not finished. They are continuing their conversation here. You see, this sends an open message. It is pushing some info. BGP is pushing some info. And then it's going from 3 to 1. And then 1 is also pushing some info. Open message. Let's go and see what is inside the open. Let's go and see what is inside the open message. You will find a router ID, autonomous system number. You see, autonomous system number, the router ID, and the hold time. I told you hold time is 180 seconds. Keep alive is 60 seconds. So these messages passed. See, it is picking the loopback interface address as the router ID. Router 1 is picking. I have selected this router 1 packet sending to router 3. And if you see here, router 3 is router ID. And same whole time is number, blah, blah. And now coming down, the keep alives. Keep alive messages. You see, that is also push, sending BGP message. Keep alive is just a ping message. Keep alive. All right? And then both are sending keep alive and then update message. Update. If you see, this is also a push. Acknowledgement with push. All right, inside the update, what do you have? It says, I don't have any update actually. That is what total path attribute length 0, meaning we have not advertised any network. So update is empty. Keep alive will be sent every 60 seconds, again update. And then there is listen. This is what the last, second last of the final. They both are now trying to finish the conversation. Okay, man, I know you now. Nice to meet you. So acknowledgement only set. And here also acknowledgement is, so both are sending acknowledgement. Okay, fine. We'll be in touch. I know you now. We are neighbors. That's it. All right. So look at this. They formed neighbor. And now if you go back to router 1 and check this command, show IP BGP summary command. This is the command which will show you the status, whether the neighbor is established or not. You see the neighbor is established. It is up for last 4 minutes and 21 seconds. If neighbor is not, listen, listen. Forming neighbor from R1 to R2, R2 to R3 is normal. Then you will not learn that BGP can form neighbor with a remote router. IBGP can be formed with a remote router. That point you will not know. What you are asking for is very normal. Farming with the next router and that now router to the following router. That is very normal. Then how you will know, when you will know, or who will show you at least once, and your environment also don't have more than 2 routers, then when are you going to learn this? Okay. Now this neighbor is up for last 5 minutes and 45 seconds. Instead of showing this timer, if it shows never, which means the neighbor never come up, the neighbor is still down. You are not seeing never here. Instead, you see a timer. And also, this place should be at least 0. This should not be idle, active. You should not have idle or active there. We'll be discussing on all these things later. What is idle means, what is active. Okay. Now, let's go to router 2 and check. You see, we don't have BGP. But still, you can form neighbor with router 3. That's the specialty of IBGP. That's the specialty of TCP protocol. All right. So even in the real world, let's say you got 50 routers in autonomous system, 10 in the real world. They will not enable BGP on every router. They will enable BGP on whatever the router that connects to the outside world. Say, for example, R3 is connecting to the outside world. R1 may also connect on the left to some other outside autonomous system. If that is the case, then only 2 routers out of 50 will be running BGP. Between these 2 routers, we will put a tunnel. We will build a layer 3 MPLS VPN or GRE tunnel. If you don't want to go with MPLS, service providers will have MPLS. If you say no, you don't want MPLS, then you will put one tunnel like GRE between R1 and R3 to avoid running BGP on every router in the middle. To avoid running BGP on all those 48 routers in the middle between R1 and R3, we will put a tunnel. That's the real world practice. Okay, now we got neighbor between R1 and R3. This proves that IBGP do not have to be directly connected. But if you don't put tunnel between R1 and R3, packet will get discarded on router 2 if you don't put tunnel. Why? Router 2 don't have roots of BGP, which we learned in the yesterday's class. When you don't have BGP on all router, the packet will get discarded in the middle. That's why we learned that we have to enable BGP on all router, full mesh. But that is only BGP. But in the real world, we are not only having BGP. We have BGP with GRE or MPLS. So if you are going with GRE or MPLS, then you don't need BGP on router 2. No need. But still you will be able to ping. Okay, those things later. Now, let's stick out to only BGP now. We saw an IBGP with router 1. Let's do EBGP with router 4. Router BGP 10. Neighbor 11 0 0 4. Remote AS 20. See, this is not the same number, but the commands are same like what we gave in IBGP. There also we use remote AS, here also we are using remote AS. Then what makes router 3 to know that this is an EBGP? It's this number. The neighbor's autonomous system number is compared with the local autonomous system number. If it is not same, it is EBGP neighbor, external BGP neighbor. If that is same, then it is internal IBGP. Okay, before I hit enter, I want to sniff packet again here. Now again, I want to filter using TCP. And now I will hit enter. Again, same story, halfway connection, SYN and then reset, SYN and then reset, you will see. Why so long? Let me check. Do I ping 11004? Oh no, there is something wrong. Router 4, I think it is not configured. Show IP interface brief. Oh no, it's not yet configured. Interface loopback 0 IP address 4.4.4.4 255.255.255 interface serial 3/0 no shet IP address 11.0.0.4. Okay, now go back and see. You will get now some packet. Look at this. Same like what we saw earlier when only one is configured. One of the neighbor is configured, not both. Router 3 is configured with router 4 as a neighbor, but router 4 is still not ready. Same story, two-way handshake only happens. Now router BGP 20. Neighbor is 11.0.0.3. Remote AS is 10. As soon as I hit enter, you will see three-way handshake followed by all those open message, keep alive message, and update message. Look at this. You see, as soon as you see the background changes here, also you see neighbor coming up. All right, now let's see it's the same story. Acknowledgement finished. You see there is a tick mark also. The session is complete. Wireshark is a beautiful tool. Now on R4, I have neighbor to verify show IP BGP summary is the command for 35 seconds. On R3, show IP BGP summary. For 41 seconds, I have this eBGP neighbor. For 15 minutes, I have iBGP. You see the autonomous system number, the local autonomous system number, and the neighbor autonomous system are same, which means iBGP. If it is different, then it is eBGP. eBGP need to be connected directly. All right.